I'd like to introduce you all to Velo. Some of you know this as the E180. This product has been under development now for over 2 years here at Nyle, and it is the culmination of everything that we've learned as a manufacturer and everything that we've been told was needed by customers. The tagline on this particular unit is everything that you want, we were not lying. This is what everyone has been asking us for over the course of several years. At a base level, the E180 is an evolution of the E360. This is part of our E-Series product line, right? The idea here is it's a cold climate air source heat pump. But we've baked in a lot of improvements, a lot of necessary feedback in order to provide something that's suitable for a lot of different situations. You can think of it as a Swiss Army knife. And the first thing I want to mention here is that this is our first variable frequency driven system from the compressor standpoint. We have variable everything on several other units, but this is the first to incorporate a variable speed compressor. It is a 15 horsepower variable frequency driven compressor. For building code in New York City, this falls under the 15 horsepower requirement. So that was one of the first requirements of this unit. That is why it is a 15 horsepower compressor, not necessarily that it's half the size of an E360. But we wanted to maximize our capacity under that 15 horsepower threshold to satisfy our friends in Manhattan and provide the next stage of our E-Series line. One of the benefits of this is obvious that we now get to take advantage of soft start, which is the loudest moment in any one of our system startup routine is the starting of the compressor. This particular system is even quieter than any unit that has come before it. We also get to take advantage of the capacity control now. So we are underclocking when we are at high capacity, high ambient. When we're at low ambient, we're overclocking to maximize our capacity closer to design so we can get closer to flattening the curve. Basically, the unit is maximizing its capacity until around 50 degrees ambient, and then we start to capacity control above that, so we're not having to oversize our buffer storage to handle that additional capacity that normally comes from a single-speed compressor. The next thing that this unit needed to do was be suitable for building retrofit. We get this feedback on the E360, it's just too darn big. We understand. We've seen it ourselves. We've been working with customers on that particular issue for years at this point. This unit was designed to fit just about anywhere. So from a visual perspective, the unit is of a width that it fits through a 36-inch door. And I'm going to have Landon here pan through the 36-inch door that it came through without taking the door off of its hinges. It slid right on through this doorway. So it's real, guys. It's a little over 34 inches wide, and the height is such that everything came through without a hitch. And they did it with a pallet jack. So Landon, as you want to pan kind of down here along the bottom, you see here we have a wide open shelf wherein the unit can be pallet jacked from either the front or the back. It also has access points on the side for a forklift so that it can also be maneuvered in that dimension as well. But this basically enables you to put this thing not only through a doorway, but its depth is such that it should fit on just about any freight elevator. So now you don't have to use a crane. You can get this thing to site whenever it needs to be at site, wherever the building is at in terms of construction phase, and it's going to be able to go up in the building with minimal logistics consideration. That drives down costs for the contractor, for everybody involved. You don't have to worry as much about coordinating ship dates and everything to try and hit those crane dates. On top of it, for those that do want to crane it into position, it does have hook points on the top, pick points on the top. So this thing can be rigged into position and the frame is built to sustain the weight. This is the first unit we've designed that has that incorporated as well. In addition to being able to fit in just through any access point or doorway that we would run into, we also, again, are always being told heat pumps are too big, taking up too much space. So we wanted to take zero side clearance to a new level with this unit. So our E360 is already a quote unquote zero side clearance unit. But because of the elements in the evaporator, if you ever needed to remove them, you would need to turn it a little bit at an angle to remove the 7-foot long electric resistive elements from it. This unit, we've gotten away from that completely. When you take a look at this thing, we do have access panels on the sides because we like our technicians so that if they have access, they can get access. But for all intents and purposes, the side panels don't ever need to be removed. You'll see the engineering team got very creative with this unit in order to make zero side clearance actually happen. So from a mechanical access standpoint, they took the front electrical panel, which is usually in the way, and put it on a hinged door, which gives us full access to the mechanical components on the front side, including the compressor, that variable frequency drive I mentioned. So on the left-hand side, you'll see a flanged large format device that's actually an electric resistance heater. There's a pump on top of it. There is a dedicated hydronic circuit in this unit that takes the place of those electric resistive elements in the evaporator that we traditionally use. So we have patented the world's first hydronic defrost for heat pump applications. Inside this unit, you have this small hydronic circuit with glycol in it and this electric resistive heater that then flows a glycol solution up into the evaporator coil to melt the ice off of the evaporator. So now we no longer need that mechanical access for those electric resistive elements, and your only service access point is down here in the cabinet where that heater is, as well as that pump. Same idea, back rear access. We have our plumbing connections, our condensate, our electrical, and then we've got a small door that enables mechanical access to the hydronic components and some of the electrical components. And you see here's our potable circuit, our recirc pump, Limo valve, etc. All components are accessible from inside or from either the front or the back. You will see that this is one of the first units to receive locking hatches to get that nice, satisfying ASMR vibe whenever you open and close this unit. And you will see those on more of our other units as we go back through and update them, but this was the first unit to receive them. All right. So moving on from zero side clearance, just understanding that when you get this thing into a mechanical space, you will now be able to put these units side by side, butted up against each other, and maximize the footprint. So you can either, obviously rooftops are still getting tighter and tighter on us, but also if you're ducting indoor applications, this thing is going to take up the least amount of room possible. While I'm thinking about it, let's talk about ducting real quick. So very unique form factor, right? This very narrow footprint, the whole side is inaccessible. So where does the airflow come in on this thing? Well, we've got our discharge on the top, as you would expect. Our fan, unlike the E360, does not sit on top of the unit. It's actually inside the plenum of this unit. So it shows up fully assembled, no field assembly required. That's feedback from customers. Nobody likes doing that, but also gives us that nice form factor and ductability. Coming around to the back, you'll see our intake for this unit. It is quite small for a 15 horsepower unit, especially if you put this thing up against the E360, which is a 30 horse unit with an evaporator basically the size of a wall. So what we've done here is taken your traditional V-coil that would be in this orientation, flipped it on its side, and we approach the evaporator from the bottom. This creates this really wonderful footprint that you really won't see anywhere else, but we're bringing that airflow in and around the sides of the evaporator, pushing through into the fan plenum and then discharging out the top. This is, from my engineering team's perspective, this is the most well-balanced coil we've ever made because we have full control of the way that the airflow flows throughout the plenum on the entering side rather than on the exit side. Very unique design. We've had a lot of pushback on whether or not it was going to work, but it has worked wonderfully and has given us this incredible form factor. I mentioned the fact that we've gone hydronic defrost on this unit. From a sequence of operations standpoint, there's no difference from what you're used to seeing from one of our units. Compressor shuts down, heater kicks on, melts ice, compressor fully cycles the oil, and by that point, ice is melted, compressor turns back on, unit comes back online. Defrost derate is included in the performance for the unit at all of its operating points. So nothing different from any of our other units in the way we've been publishing data, but that does go back to, unlike having a reversing valve or having hot gas, we're not starving heat from our hot water in order to defrost our coil. I'm going to come back to my first statement on the variable frequency drive. The main reason why we chose a variable frequency drive for this unit was to do something new, which is to take ourselves from the two choices of either single pass or multi-pass and incorporate the ability to both in one machine and also enable a new operating mode, which is single pass return to primary, which is essentially taking those two methods and combining them. Now we can handle recirc loads directly by the heat pump in a single pass orientation. And this enables some interesting design conventions that Bryce is going to touch on afterwards here. But essentially why we had to have a variable frequency drive compressor to do this is a hydronic reason. We have our E360 and our Electro, for example. They're basically the same thing, one's single pass, one's multi-pass. It's not a limitation of the refrigerant or the refrigerant circuit or the compressor itself, but it's a hydronic limitation. In order to have a usable pump, you have usable head available, we would need to be able to vary, like the E360, for example, from 1 gallon a minute to 35 gallons a minute under various ambient conditions and various entering water temperatures to do what this machine does. Because we have capacity control on this machine, we're able to take that flow range and shrink it. And now we can behave within a range that is acceptable for a pump that is usable for our application. There is no variable frequency drive pump that can handle that wide of a flow range while providing you suitable head. So that capacity control from the variable frequency drive enables us to do that. That's going to be very unique in on anywhere. You see people trying to replicate that. This is the only machine that has been designed from the ground up to handle that specifically. So what does that look like from a performance standpoint? This particular compressor actually outperformed all expectations. And inside of its envelope, it's able to make 160-degree hot water at very narrow delta T's all the way down to 10 degrees ambient. So this is the first unit that when you look in the manual at the leaving water temperature derate curve, it's just a straight line, 160 all the way across. The unit's actually capable of making hotter water than that. More to come on that front, but this is one of those pieces of equipment where you go to an engineer and you say, when I say 160, I mean 160 across the entire envelope. This unit does have a higher value per BTU than our E360 because of that ability to overclock the compressor. This unit has 75% of the capacity of the E360 at 10 degrees. So with half the compressor horsepower. That's a huge gain for all of our cold climate folks who need that extra capacity at their design day. Enables less equipment, more cost-effective installs. We can do system designs where we no longer need a swing tank. No more leaning on electric resistance when we don't have to. Very unique opportunity. And from a equipment standpoint, it's not a different unit. So you want a unit that does single pass swing or single pass return to primary or multi-pass, it's the same unit. You're only going to have the SKU specific to the input voltage for this unit because those are the only differentiators. Everything else is just a click on the UI to change the operating mode to handle that particular condition. It's got the same ECM plug fan from EBM PAPs that the E360 has. It just has one of them instead of two. So inside this plenum is one of those plug fans. It's going to give us a little over 2 inches of external static. And again, maximize that ductability for those engineers that want to put these units inside. We're still going to be outdoor rated to minus 13 degrees, same as the other units. You can put this thing outside or inside. It can also go out on a rooftop just as readily. It's going to have NSF 61, UL 60335-40, all table stakes for us. You got your low GWP refrigerant, R513A, just like the rest of our product line. A1 class, non-flammable, non-toxic. Again, native voltages, we've got our 208, 230, and our 460 volt.